Today's lesson is going to revolve around the sine and the cosine. Previously, we've talked about the tangent function, and with it, we had to talk about how, based on angle A, we would have the opposite leg, the adjacent leg, and the hypotenuse. Well, very similarly, using this SOHCAHTOA business, SOHCAHTOA, we were able to come up with the idea of sine being the opposite over the hypotenuse, and cosine being the adjacent over the hypotenuse. We're going to take a look at these two, hopefully find side lengths, areas, perimeters. There's a lot of different ways we could talk about this. We'll also look at the ideas of angle of elevation and angle of depression. Use the cosine or sine ratio to find the value of each expression, round decimals to the nearest tenth. So in this case, when I have problems like this, what I usually do is I try to do this in alphabetical order. Everything is going to be based on 57 degrees. So from 57 degrees, this is the opposite side, this is the hypotenuse, and this is the adjacent side. If I just ignore B for just a little while, I just look at A. If I'm looking for A, and I have 14, that means I have the adjacent and the opposite side. So that means with adjacent and opposite, I have to use TOA. So that's tangent of 57 degrees equals the opposite over the adjacent, which is just A. I'll cross multiply and divide, and I'll have A equals 14 divided by the tangent of 57 degrees. Again, that's cross multiplying. This would be giving me A times the tangent of 57 degrees, then I'll divide both sides by the tangent of 57 to get this. In my calculator, A would equal approximately 9.1 to the nearest tenth. At that point, I ignore A, and I focus primarily on A. Wow, I ignore A and I focus primarily on B. With B, I now have the opposite and the hypotenuse, so I have to figure out which function I have. I use the sine function. So the idea is because I have opposite and hypotenuse, that's the, I would use sine because that's SOH. So the sine of 57 degrees is going to equal 14 over B. When I cross multiply and divide, I'd have 14 divided by the sine of 57 degrees. And that would give me approximately 16.7 round to the nearest tenth. The next problem works pretty much identically. The idea here is here's 47 degrees. This becomes my hypotenuse. This becomes my adjacent side. What I'm given is my opposite side. What I do is I focus on one side. I'll talk about, I'll just do this alphabetically, so I'll focus on C. I'll ignore D for right now. If I have my opposite and adjacent, again I'll use the tangent function. Tangent of 41 degrees equals my opposite over my adjacent. I'll cross multiply and divide. That's 17 divided by the tangent of 41 degrees. And C would equal approximately 19.6. Now I'll ignore C completely, and I'll focus primarily on the opposite and hypotenuse. Opposite and hypotenuse, again is sine. So the sine of 41 degrees is going to equal the opposite, which is 17 over D. In this case, D would equal 17 divided by the sine of 41 degrees, which means that D is approximately 25.9, like so. Third problem, actually, I don't understand this, but they give you the exact same information again. They give you the adjacent side and the hypotenuse. It's kind of annoying to work this way, so we're not going to do three problems that are exactly the same three in a row. On the back side, we have something else that talks about using the 45-45-90 triangle theorem, or the 30-60-90 triangle theorem, to find the sine and cosine of, in this case, the 30-degree angle. So in this case, we'll obviously use the idea of a 30-60-90 triangle. So let me draw this up here. We know this is a 30-60-90 triangle. It does not look much like one. Here's 30, here's 60, and there's the 90-degree angle. Let me see if I can connect those a little bit. Looks kind of like a really ugly foot. The idea here is if we were talking about 30 degrees, this is going to be our opposite side over here. This is our adjacent side down here. This is our hypotenuse over here. Dealing with those 30, 60, 90 triangle pieces, remember we really liked this part. We called this the short leg. This was the long leg, which was basically short leg times the square root of 3. And this was the hypotenuse, which is basically 2 times s, or 2 times the short leg. And we'll use those ideas based on those 30 degrees to talk about the sine and cosine. So sine of 30 degrees, remember sine is always the opposite over the hypotenuse, so that would be s over 2s, which just equals 1/2. And if you type in your calculator, if you type in the sine of 30 degrees, you will get 1/2, or you'll probably get 0.5 in your calculator. Next we'll talk about the cosine of 30 degrees. Cosine is always the adjacent over the hypotenuse. The adjacent side here is s times the square root of 3. That's an s. S over the square root of 3 over 2s. The s's will cancel and we'll basically have the square root of 3 over 2. And that is the exact answer of what you get back in your calculator. When you put that in your calculator, you get something like 866, I don't know, 0 maybe. And these are the exact answers. This is the exact answer, and this turns out to be the decimal representation of that. A long time ago when we talked about the unit circle, when I showed that to you, it was a little intimidating. This is actually one of those things that came up quite a bit, was the square root of 3 over 2, dealing with 30, 60, 90 triangles. It says find the unknown side length, then find the sine of A and the cosine of A. Write each answer as a fraction in simplest form and as a decimal, round to 4 decimal places if necessary. So the idea here is that we'll need to find the side here. We'll just call this x. Because it's a right triangle, we can use the Pythagorean theorem. This is our hypotenuse, so we'll just say x squared equals 51 squared plus 140 squared. Putting that in my calculator and taking the square root, I'll get x to be exactly 149. So that's finding x. Next we'll find the sine of A. From A, this will be the opposite side. This is the adjacent side. And this down here is my hypotenuse. So the sine of A is going to equal the opposite, which is 51, over the hypotenuse, which is 149. 149. As a decimal, that would be 0.3423 to 4 decimal places. So this is the exact, and this is the decimal representation. Maybe I'll just circle this whole thing here. That'd be fairly useful. Next we'll do the cosine of A. Cosine of A is the adjacent over the hypotenuse, which looks like this. You can't simplify that fraction, but you do get a nice decimal, and I think you have to round that 6. You probably have to round that 3 to get the answer as well. So here's my answer, the exact answer, and the other answer, just like that. Number 16, very similar to it. Why don't you guys give it a shot, and I'll come up with some answers in just a second. So pause right now, and we'll look at an answer in just a second. Hopefully you got this leg over here to be 160. This is the adjacent side when you base it on A. From here, this is the opposite side. This is the hypotenuse. In this case, the sine of A needed to be simplified to 40 over 41, which is 0.9756. And the cosine of A also needed to be simplified to 9 over 41, which would equal 0.2195. Next we're talking about the angle of elevation and the angle of depression. This is the idea that if you are staring straight off, this person, if that's you, then your eyesight goes straight out. If you need to move your eyes down to see your friend, that's going to be called the angle of depression. Not because your friend makes you sad, but because you have to look down to see your friend. If this is your friend right here and they look straight out, and they need to raise their eye level in order to see you, that would be the angle of elevation, not because they elevate you or put you on a pedestal, but because their eyes have to go up in order to see you. There's one example problem that I'm going to show you dealing with skiing on a mountain. It says you are skiing on a mountain with an altitude of 101,200 meters. Wow, that's pretty high. The angle of depression is 21 degrees. About how far do you ski down the mountain? The idea is if they did not provide you with a picture, you would need to know that you are 1,200 feet in the air, and that when you look straight out, that's 0, and when you look down at a 21 degree angle, that's what you're looking at. So we're really looking at this angle right here, and we're trying to find basically the hypotenuse of this. This is my opposite side from my angle. This is the hypotenuse. So opposite and hypotenuse tells me I need to use the sine function. So the sine of 21 degrees equals the opposite over the hypotenuse. I'll then cross multiply and divide. X is going to equal 1200 divided by the sine of 21 degrees, which should equal 3,348.5 meters. Sometimes rounding the nearest meter is what you need to do, sometimes rounding the nearest tenth. Sometimes the directions will tell you. When in doubt, nearest tenth is usually a pretty good place to be, unless you have a really small number, then maybe the 100th or 1000th place. We've explored sine and cosine. Hopefully this has been helpful for you. You can always go through the book or look at other places online in order to find interesting things about sine and cosine. If you need some help, let me know. In case you're interested in some extra challenging problems, and you don't believe me that sine and cosine and tangent are everywhere, here's a man fishing with a bunch of angles, and here's trigonometry all piled up. This would be a pretty sweet extra credit question at some point. Try it out if you dare.